So in this video, we're going to be looking at how we can use IUPAC, the International Union of Pure and Applied Chemistry's method of naming things, and we're going to look at how we can draw compounds using displayed formula as well. So yeah, if we were to start off, nomenclature, what does that actually mean? Well, it's just a posh word for how we can name things, and I like to follow a series of rules to make sure I get the mark every single time, so I get the structure right every single time. I like to start off by finding, first of all, the longest carbon chain. Now the next thing is I like to find any branches, any functional groups, and highlight those as well, and then number my carbon atoms from the branches and functional groups with priority, and then put it all together in alphabetical order. If I've got multiple branches or multiple groups, I would need to use the following system, where let's say if I had a branch of methyl, I would just call it methyl. If I had two methyl groups, I would have, of course, dimethyl. If I had three methyl groups, it would be trimethyl, and then if I had four groups, it would be tetramethyl itself. Now, as we mentioned in a previous video, we've got a prefix, we've got a stem, and then we've got a suffix. The prefix is going to be the starting bit, the suffix is going to be the ending bit, and these two will tell you about the functional groups and branches that you've got. The stem, though, is going to tell you about the number of carbon atoms that you've actually got in the longest carbon chain. We're going to try a few examples. By all means, feel free to pause the video at any time, have a go yourself, and then of course we'll go over the answers together. So starting off with this first one, we need to find the longest carbon chain. It's a straight chain, there's no functional groups on it, so we don't need to label anything on there. But if we were to label the number of carbon atoms, I've got 1, 2, 3, 4, 5. I know it's an alkane, there's no other functional groups on there, so I know my stem is going to be pent, and then it's going to end in ane because it's an alkane. The first one's pretty much nice and easy, a GCSE example. So looking at the next one, then you can see my longest carbon chain is going to be 3 in this case. I could go from left to right, right to left, doesn't really matter. Could even go up if I wanted to, but I can't go back on myself. That's the rules when it comes to it. So my longest carbon chain is going to be 3. So my stem in this case, we know it's going to be prop. Now if I were to look at this, it's an alkane, so I know it's going to end in ane, so it's going to be propane. But the thing is, I've actually got a branch on here itself. Now that branch, because it only contains one carbon atom, this branch we call it an alkyl group, but to be specific, it's a methyl group. Now if I were to label my number of carbon atoms, which again, remember, it doesn't matter, I've got 1, 2, 3. On the 2 position, I've actually got my methyl group attached there, and so I would end up naming this with the prefix of 2-methyl. The reason why we have a hyphen between the 2 and the methyl is because to separate the numbers from the letters, we need to show and make that obvious, and we do that by, of course, adding a hyphen. If we're separating numbers from numbers, we would use, of course, commas. So there's my prefix there, and then of course my stem is going to be prop because I've got 3 carbon atoms, and then my suffix is going to be ane because it's just an alkane. So yeah, that's those two done. What about if you were to look at some trickier examples over here? Well, again, you can pause the video and have a go yourself, but in this case, right, you can see my longest carbon chain is going to be 1, 2, 3, 4, 5, 6, and it's going to be the same thing in the opposite direction as well. But we need to think about this in terms of our branches, right? So we've got 1, 2, 3 branches over here. We've got 3 methyls. That means, of course, we would call it trimethyl itself. Now if I were to number it from left to right, I've got 1, 2, 3, 4, 5, 6 carbon atoms. I know my stem is already going to be, of course, hex. I know it's going to end in ane because it's just an alkane. It's not an alkene or anything else. So that's the stem done, that's the suffix done. So we need to think, of course, what about our prefix? That's going to be trimethyl because we've got 3 carbon atoms there, and we've got 3 alkyl groups, 3 methyl groups there, but we need to highlight the positions of each one. So I'm going to separate the positioning, the numbers from the actual prefix itself, the numbers from the letters itself, using a hyphen, and then I'm going to add the positions of each one of these methyl groups. I've got 2, 3, 4, so I would end up with 2, 3, 4. We need to make sure that we've separated out our numbers from letters using hyphens and our numbers from numbers using commas. And what I've done is I've made my prefix here saying that I've got 3 methyl groups where the positions are going to be on the 2, 3, and 4 position. Now that's how we would name this one. Now a problem with this is that we can actually end up naming this wrong by accident, because let's say if they flip the molecule, you might accidentally go from left to right again, but you have to look at it from every direction. Now let's say if I were to speak a different language where I read from right to left, automatically I might think that I go 1, 2, 3, 4, 5, 6 over here. And this is where our second and third rule actually become quite important. If I were to look at this, I'm going from right to left, 1, 2, 3, 4, 5, 6. I actually have my methyl groups on the 3, 4, and 5 positions. So let's say if you did go from right to left, you actually end up with a different name. You would actually end up with, from right to left, 3, 4, and then 5, and then it would be trimethyl again, and then it would be hexane. Now this one would actually be wrong, and the reason why is because you don't actually have the smallest possible numbers overall. You haven't actually numbered the carbon atoms from priority, from where you first meet the methyl, the ethyl, doesn't matter what alkyl group it is or even what functional group it is. If you meet a functional group first on one side compared to another, you would number it from that side itself. So in that case, the purple will be wrong, the light blue would be right. So you're looking at the next one. I've got here carbon, 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 carbon there. 5 carbon atoms overall. Now in terms of my branches, I've got 1, 2, 3 alkyl groups that are all going to be methyl, so it's going to be trimethyl again. Now the thing is, if I were to look at numbering it, I could go from left to right or right to left again, but the thing is, if I look at it going from right to left, I've got 1, 2, 3, 4, 5 over here. But the thing is, if I went about it going from left to right, I've got 1, 2, 3, 4, 5 over here. If I were to look at it right, I actually meet the methyl group over here first, and I also meet a methyl group over here. But because in the light blue method I've actually got 2 methyl groups that are meeting on the 2 position compared to 1 in the purple method, I would take priority over right to left compared to left to right. So in that case, right, we don't actually go with the purple one, we're going to go with the light blue one. So again, my stem is going to be pent because I've got 5 carbon atoms. It's an alkane, it ends in N. There's my suffix done. My prefix is now going to be, because I've got positioning of 2, 2, so I've got a methyl at 2, another methyl at 2, so I need to say 2, 2, 1 for each methyl, and then I'm going to have comma, and then it's going to be 4, and then I'm going to have trimethyl. I'm running out of space as well, so I'm going to move that over to the right a bit because it all needs to be one big word. Trimethyl, and then it's going to be pentane itself. And there's that one done as well. Yeah, we've avoided the silly mistakes and we've stuck to the method that I've shown you here. So yeah, let's try another 2 then. We've got here alkenes now, and we can see that quite clearly because of the carbon-carbon double bonds. So again, we need to follow the same method as before. We've got carbon 1, 2, 3, 4, 5 carbon atoms over here, and we need to think about where our functional group is. We've got here a carbon-carbon double bond. Now, which way would we number it? Well, we've got to think about what we talked about before. We meet the functional group on this atom over here, this second carbon atom over here, compared to if you went with the other way where we would have met it on the 3rd position instead. Now with alkenes, we normally go with where we meet the first carbon atom that's within the double bond itself, and I'm going to go with the light blue method again. So I've got 1, 2, 3, 4, and then 5 carbon atoms there. So I know my stem is going to be pent. I don't actually have a prefix, but here's where it gets a bit interesting because we're dealing with a functional group, and the functional group is going at the end. In this case is a suffix. We need to think about what position it's at. It's at the 2nd position to name alkenes with respect to their position for the actual carbon-carbon double bond. We would say where the actual alkene starts. It's going to be at the 2nd position. So I'd put pent, and then it would be 2, and then we end it in ene to show the functional group and its position as well. And there's that one done there. What about the next one? Similar type of thing. I've got 1, 2, 3 carbon atoms there in total. I could go about it that way, but the only way I can't go about it is like this, because that would actually be wrong, because our alkene is going to take priority in terms of numbering. So yeah, I look at it, I've got a methyl group over here, and I've also got my alkene functional group there. Now in terms of the numbers, I've got 1, 2, 3 again, because we want to get the smallest numbers possible. In terms of my prefix, I know it's going to be 2 as a position for my actual methyl group. So it's going to be 2 methyl, and then I've got 3 carbon atoms. My stem is going to be 3 prop, and then I'm going to end up with the alkene at the 1 position. So I'm going to say 1-ene itself for my suffix. There's that one done there. Just be sure that you're looking at the first carbon atom here. It's going to be prop 1-ene, not prop 2-ene itself. Now in this example, in the exam, they actually ignored the numbers because it can only be at the 1 position, and to have a branch it must be at the 2nd position, because you can't actually get the branch at the end of the chain because that would just extend the length of the carbon chain itself. But yeah, moving on, 2 more examples here, some tricky examples, you might want to have a go at them as well. So yeah, same type of thing over here. We need to find the longest carbon chain. 1, 2, 3, 4, 5, 6 carbon atoms all together. Don't forget that you can go up, down, left, right. You just can't go back on yourself like this. So yeah, we've got 6 carbon atoms there. I've got 1 branch over here, alkene over here. So I've got 1, 2, 3, 4, 5, 6 carbon atoms all together. My stem is going to be hex. It's going to end in ene again, but we need to highlight the position of the alkene. But I've got a branch on the 4 position as well. So in that case, I've got 4, only 1 methyl, not 2, don't make that mistake. 4 methyl, and then it's going to be hex, because I've got 6 carbon atoms, and then I'm going to have the alkene starting at position 1, so it's going to be hex 1-ene. Of course, it wouldn't be hex 5-ene if you were to go in the opposite direction, because we want the smaller numbers. And when it comes to groups of priority, the alkene takes priority over any branches. So the alkene, you meet it at position 1, regardless if it was at position 2 or 3, it's still going to take priority compared to any branches, any alkyl groups. So there's that one done there. What about the next one? That's quite tricky. It looks quite messy, this one, but again, we've got here 1, 2, 3, 4, 5, and then 6 carbon atoms. Maybe I could go another direction. Doesn't really make a difference. I'm going to go with, of course, left to right, directly straight, just to keep things easier. Now, what functional groups and branches have I got? Well, I've got 1 alkene there, another alkene there, a branch here, and then I've got a branch here, and then a different type of branch there. Now, of course, this, because it contains 1 carbon atom, it's a methyl group. It's a methyl branch. It's not going to be, of course, any alkyl. We need to be specific and say it's a methyl. Whereas this one over here, because I've got 2 carbon atoms, I wouldn't call it methyl anymore. It's still an alkyl group, but we call it an ethyl group because it's got 2 carbon atoms. Think F, think ethane, think ethyl. So yeah, I've got there ethyl, methyl. Need to highlight the positions now. 1, 2, 3, 4, 5, 6. Now this one's quite complicated. You need to think about how you would actually name it. Well, you've got to begin with 2 methyls overall, so we're going to change that to a dimethyl, because you've got 1 here on the 3 position and you've got 1 at the 5 position. So I'm going to put 3, 5 hyphen dimethyl itself. Now what about the ethyl group, because that's at position 4? Well, I'm going to have 4, and then it's going to be ethyl itself. There's one part done there. So again, you're separating numbers from numbers using commas, numbers from letters or words using hyphens itself. Now what about my stem? My stem is going to be hex because I've got 6 carbon atoms. What about my suffix here? Because this gets even more challenging. Well, I've got my carbon here as position 1 and 3 as being the starting point of both of my actual alkenes itself. I've got 2 alkenes here. So I need to think, if I've got ene, diene must be for 2 alkenes. Triene must be for 3 alkenes. We followed the same rules that we looked at here before. So in that case, I'm going to have diene, but remember there's 2 different ways to name it. This is where it gets a bit trickier. So yeah, if I were to put this all together, right, I'm going to have, first of all, 4 ethyl, then 3, 5 dimethyl. The thing is, I can't actually just stick them together in any order. It needs to be in alphabetical order, where I've got E here and I've got M there. Now, if E comes first in the alphabet, which I hope it does, you're going to end up with 4 and then ethyl to begin with. And then you're going to separate it out using another hyphen. You're going to add 3, 5, and then it's going to be dimethyl again. And then you're going to end up with your stem, which is of course going to be hex. And then your suffix, which you can go ahead and name this and say it's hex A, and then hyphen, and then state the positions where you've got 1 and then it's going to be 3 diene. Now this is what the examiner expects you to be able to kind of write out, but another name that they actually prefer is, of course, the first bit's going to be the same, where you've got 4 and then it's going to be ethyl, 3 5, and it's going to be then after that di, and then it's going to be methyl, and then it's going to be hexane. So instead of hexa, put hexane, and then you're going to have 1 3 and then diene again. So yeah, the examiner accepts either one of these two, and they actually prefer the one at the bottom. Quite a tricky example, but again, it's something realistic that comes up on the exam. So yeah, moving on then, looking at the next example, I've got here some slightly easier ones. In this case, right, we're dealing with alicyclic compounds, which of course are going to be alkanes, but we actually call them cycloalkanes. And to name these, we just find out however many carbon atoms we've got in the ring. We end up with a suffix because it's an alkane as being N, and then our stem is going to be hex, but then our prefix here changes to show it's alicyclic. We say it's cyclo, and then we've got hexane itself. And there's that one done. So you're looking at the next one, we've got here again another alicyclic compound. We already know the prefix is going to be cyclo, the suffix is going to be ane, and the stem is going to be 6 because we've got 6 carbon atoms, but we've got here a branch as well, so we start numbering it from this branch as well just in case. And we actually have here 6 carbon atoms, and on position 1 we've got a methyl group. Now you would call this 1-methyl cyclohexane, but you can ignore the 1 position because regardless of where it will be, it will always start off as being position 1. So in that case, if we've only got 1 functional group on there, 1 group on there, and we always label it as 1, this is a rule that only applies to alicyclic compounds, then in that case we can say it's going to be just methyl cyclohexane, because it could have been over here, but then that would change this 3 to a 1, could have been over here, but that would change that 5 to a 1, and so on. So we've got over here methyl, and then it's going to be cyclo, and then it's going to be hexane. There's that one done too. 2 nice easy examples. I've got some examples for you to try now. Feel free to pause the video, follow the same rules again, have a go, and then resume once you're ready to go over the answers. So yeah, following our rules, what's our longest carbon chain going to be? Well, I've got 1, 2, 3, but don't forget you can go up or you can go towards the right. So in that case, I'm going to go from left to right over here. I've got 4 carbon atoms. So that means I've got a branch here, and branch there. Now, which way would I actually name this? Well, if I go from left to right, I would have carbon 1, 2, 3, and then 4. But if I went from right to left, I would have carbon 1, 2, 3, and then 4 itself. Now you can see here again, similar to an example that we looked at before, I can either end up with 2,2-dimethyl, or I can end up with 3,3-dimethyl, and I'd prefer to have, of course, smaller numbers for these methyl groups here. So in that case, right, I'm going to go from left to right in this case, so I end up with 2 lots of 2 and 1 lot of 3 rather than the other way around itself. So yeah, my stem in this case is going to be, of course, bute, because I've got 4 carbon atoms. My alkane is what I'm dealing with. That's a homologous series, so we know it's just going to be butane. So yeah, if I were to put everything together, I've got 2, 2, 3 for my positions of all of my methyls. Remember, I've got 3 methyl, so it's going to be trimethyl, and then it's going to be bute, because I've got 4 carbon atoms in my longest carbon chain. It's going to end in ane because it's an alkane, and there's that one done. So looking at the next one then, my longest carbon chain is 1, 2, 3, 4, 5 carbon atoms. I know I've got here an alkene over there. I've got a methyl group over here as well. Which way would I number it? Well, if I number it from right to left, I end up with my carbon atom over here being on the 3 position, but left to right, the carbon atom actually ends up on the 2nd position for the alkene. Remember, that's what takes priority. I also end up with, of course, this is going to be my 3 position where I have my methyl, and then I've got 4 and then 5 over here. So yeah, if I were to name this, I know my prefix is going to be 3-methyl. And then my stem is going to be pent because I've got 5 carbon atoms. I'm going to have a hyphen, and then it's going to be 2, and and then it's going to end in "ene" itself. So I've got 2 hyphens there to separate the numbers from the letters, and there's that one done. Look at the next one. The next one looks quite tricky. We've got 1, 2, 3, 4, 5, 6 carbon atoms all together, and so I know my longest carbon chain is going to be 6. In terms of my branches and groups, I've got 3 branches over here, and then I've got a functional group here for an alkene. Straight away I number it from here left to right, and then I go up as well. Don't forget that one. That's a common mistake. I end up with hex for my stem. My suffix is going to be, of course, my ending part is going to be 1, and then it's going to be "ene" because that's the first carbon we meet the double bond at. And then of course I end up with my trimethyl with the positions being 3 and then 4, 4 itself. So I end up with 3 and then 4, 4, and then it's going to be methyl, and then it's going to be hex hyphen, and then it's going to be 1-ene. Trickier example there, but again, a lot of these are quite tricky and they come up quite a lot in the exam. So looking at this next one's quite tricky as well. Again, we've got 6 carbon atoms, so we already know our stem is going to be 6. It's going to be hex. I've got a branch here, branch there, and I've got an alkene there. Now if I were to start numbering it from here, I would end up with 1, 2, 3, 4, 5, 6, which is bad because we end up with big number of 6, and then we end up with a small number of 2. But the thing is, if I were to move the position of the first carbon atom and say, rather than it being that carbon atom on the alkene, if I were to move it to the other carbon atom, I would end up with this being position 1, that's going to be 2, and that's going to be 3 itself, going clockwise again. So yeah, I end up with 6 carbon atoms. I've got a methyl group on position 1 and 3, compared to before where it was all the way at 6, and then I've got my alkene still at 1 as well. So how would I name this? Well, I'm going to have 1 and then I'm going to have 3, and it's going to be di because I've got 2 of them, and then it's going to be methyl, and then I'm going to have, of course, cyclo because it's going to be alicyclic, and then I've got 6 carbon atoms, so it's going to be hex, and then it's going to be an alkene at position 1, it's going to be ene itself, and there is that one done too. So yeah, that's how you can name organic compounds using, of course, the IUPAC rules in nomenclature itself. But what about if we were to draw them instead? Well, we normally use displayed formula in GCSE and A-level chemistry, but I prefer to use something that's accepted on the exam, and you need to know it anyway. It's skeletal formula. Now, displayed formula, we define it as the formula showing the relative positioning of all atoms in a molecule and the bonds between them as well. So we need to show every single bond. Remember that in displayed formula. Now, a rule that we generally follow is that something like carbon can form a maximum of 4 bonds, something like hydrogen forms a maximum of 1 bond, oxygen a maximum of 2, and nitrogen a maximum of 3. Now remember, in some cases you can end up with more bonds, in some cases you can actually end up with less bonds, but we're going to ignore that for now. Now if we were to draw out compounds, here's what I like to do. I like to start off with the stem first, where I've got bute, so I know I've got 1, 2, 3, 4 carbon atoms, and then I like to add the functional group in. I've got 1-ene, so in that case I know in the 1 position I've got an alkene there, and then of course I like to fill out all of my carbons with hydrogens, making sure that they've all got 4 bonds. So I've got 2 bonds missing there, so I'm going to have 2 hydrogens. I've got 1 bond missing there, I've got 2 bonds missing there, and then at the end I've got 3 bonds missing over here as well, and there's that one done. What about the next one? Well, we've got bute again, so I'm going to have 1, 2, 3, 4 carbon atoms, and then of course it's just going to be an alkane, but we've got 2 methyl groups at those positions, so I'm going to end up with a methyl group over here. I'm going to draw it slightly longer as well. I'm going to end up with a CH, HH, and then H here as well. And then the same thing on this one, but I'm going to do it the other way just because it's just easy for me to draw. And then of course we end up with our hydrogens that are missing. We're going to stick them on there as well. I've got my hydrogens all here added on too. Just be aware that you need to make sure that every carbon has 4 bonds, and any missing bonds is obviously going to go to a hydrogen, and there's that one done there. Now of course I've got a task for you to try. Feel free again to pause the video, have a go at the following, and resume once you're ready to go over the answer. So yeah, the first one, we've got methyl propane. That's 3 carbon atoms there. So I'm going to have 1, 2, 3 carbon atoms like that. And then we've got a methyl at the 2 position. So the second carbon atom, you can number these as well if you want, if that makes things easier. And I end up with filling out my remaining bonds with hydrogen atoms. Just be aware that, of course, every carbon atom should have 4 bonds. Looking at the next one then, we've got 1,2-dimethyl cyclobutane. So I'm going to start off with cyclobutane. If that's 4 carbon atoms, that can kind of look like some sort of a square. So I end up with that. And then I'm going to end up with 2 branches on the first and the second position. So I end up with carbon bonded to hydrogen here, hydrogen there, and hydrogen there. Another carbon here, that's going to be position 1. We'll see. I'll actually number this one. There's 1, 2, 3, 4, 5. I'm going to end up with a hydrogen here, and then hydrogen here, and then a hydrogen here as well. And then I'm going to end up with, of course, my carbons need to have 4 bonds to them. My hydrogens that are missing, I need to add them on again over here as well. And there's that one done too. Looking at the next one, we've got here bute. That's our longest carbon chain. That's our stem. We've also got an alkene at the second position over here. So it's going to be over here. I'm going to number this one again just to create the habit. And then I'm going to end up with a methyl at the second position. So I end up with CH3 over here. And then I'm going to end up with, of course, my remaining hydrogen atoms. Just be sure that you don't actually make any silly mistakes when it comes to alkenes, because they've already got 2 bonds going to the carbon atom on the left, 1 on the right. So you only need to attach 1 hydrogen on there. Same thing over here as well. And then I'm going to end up with hydrogen, hydrogen, and then hydrogen itself there. Now, when it comes to alkenes, what I would avoid doing is drawing out my structure like this, because what that tells me in my brain, it tells me that I've got a missing hydrogen here, and you feel compelled to actually write in that missing hydrogen. So I would avoid that. What I'd prefer that you do is of course, add in your carbon-carbon double bond, but then spread out your hydrogens so you know there's nothing missing on there. So you already know that that carbon should have 2 hydrogens attached. It prevents you from making these silly mistakes. So yeah, looking at the next one, a bit tricky. We've got pent-1-ene. So again, I've got 1, 2, 3, 4, and then 5 carbon atoms all together there. And then I'm going to have, of course, an alkene at position 1. But position 3, we've got an ethyl group. So that's going to be 2 carbon atoms going this way, and I am running out of space. I'm going to move it down towards the right this way. So I end up with, again, my hydrogens need to be added on. I'm going to do what we said that we prefer. I've added my hydrogens there. I've added my hydrogen here, and then another one there. And then I need to make sure every single carbon atom has 4 bonds. And in this case, you can see I've ended up with something quite messy, but it looks like this. This is why I don't like displayed formula. Skeletal is the best. And yeah, there's that example done, hopefully with no mistakes, along with the last one as well.